For more than a century, textbooks have spoken of wave-particle duality, as though light and matter must wear two different masks depending on the experiment. Yet in modern physics this picture is seen as outdated. Quantum objects are not sometimes waves and sometimes particles, they are unified entities described by a wave function, or in quantum field theory, as excitations of underlying fields. What appears wave-like in one context and particle-like in another are simply different aspects of the same quantum description. In other words, duality is no longer regarded as a paradox but as two experimental windows on a single reality. Contemporary theory replaces the old metaphor with language of superposition, probability, and fields, providing a more consistent account than the wavering back and forth of the early days. While the language of quantum theory has evolved, the mathematical machinery remains much the same. Whether it is Schrödinger's wave equation, which describes the evolution of a system's wave function, or Heisenberg's matrix mechanics, which encodes the same information in a different form, both approaches are equivalent ways of handling the same quantum formalism. These frameworks, first developed a century ago, are still the backbone of modern quantum mechanics. Now, Augmented Newtonian Dynamics directly challenges that view. It gives structure to the photon, treating it not as a featureless quantum of energy but as a real, physical entity. And it reinterprets the electron not as a passive charge carrier, but as a dynamic particle that continually strives to maintain its energy intact. By doing so, theory removes the need for arbitrary dualities and exemptions, offering a framework where the same physical principles apply consistently from the smallest scales to the largest. Wave-particle duality was first invoked to solve a basic paradox. If electrons were simply orbiting the nucleus as charged particles, they should radiate away their energy and collapse into the atom's core. To avoid this, quantum mechanics declared that electrons were not really particles at all, but mysterious entities that sometimes behaved like waves, sometimes like particles, and could only be described in terms of probability. These waves were described by a wave function. In time, this wave-particle idea was hardened into doctrine. Heisenberg had famously insisted that only measurable quantities should be included in physics, yet the electron's wave function was not a measurable quantity at all, but an abstract mathematical tool. Still, under Heisenberg's pragmatic shut-up-and-calculate philosophy, it became accepted as the standard description of the atom. With the influence of de Broglie's matter waves, Schrödinger's wave mechanics, and Heisenberg's own matrix formalism, the wave function of the electron grew into the foundation of modern quantum mechanics. Alongside the Pauli exclusion principle and the Aufbau principle, the doctrine of wave-particle duality gave physicists a powerful mathematical framework for explaining the structure of atoms and the arrangement of electrons in shells. It worked, at least mathematically, and the success of these equations filled in the gaps left by Bohr's early atomic model. But at its heart, the wave-particle duality remained a conceptual stopgap, masking the fact that the true physical mechanism of electron stability within the atom had yet to be properly understood. But there is another explanation, one already accepted in nuclear physics. Within the nucleus, protons and neutrons are stabilized by constant self-interactions mediated by massless particles called gluons. This dynamic process prevents them from simply decaying into chaos. Why should electrons be any different? Augmented Newtonian Dynamics proposes that electrons also stabilize themselves through continuous self-interaction, not with gluons but with photons. By emitting and reabsorbing photons in rapid succession, the electron maintains its energy balance and remains in orbit, without needing to collapse into the nucleus. To sum up, the electron self-stabilizes its orbit around the nucleus without the possibility of radiating away all of its energy and spiraling into the nucleus. This process removes the need for wave-particle duality entirely, at least in its most basic form, restoring the electron to its rightful place as a real, measurable particle that does not flicker between wave and particle avatars. Augmented Newtonian dynamics takes a very different path. Instead of treating the electron as a wave-particle hybrid held in place by abstract probability functions, it explains electron stability directly through a process of virtual self-interaction, where the electron emits and immediately reabsorbs photons. In quantum mechanics, these interactions with the vacuum are seen as random fluctuations with no internal order, and the wave function is used as a mathematical tool to describe probabilities. In contrast, AND theory views the process as an ordered, self-regulating interaction that allows the electron to maintain its energy and stability without resorting to wave-particle duality. From this basis, AND theory proceeds step by step. The spin of the electron is no longer a mysterious quantum number, but a property with a clear physical explanation. The Pauli exclusion principle arises naturally from this same process, without needing to be imposed as a separate rule. Even the Aufbau principle, which governs the filling of atomic orbitals, is explained within the same framework. Most importantly, AND theory removes the need for strange, non-physical orbital shapes. Instead, electrons can occupy ordinary orbitals that follow simple paths in a plane, fully consistent with observation yet rooted in real. In quantum field theory, photons are described not as little particles emitted directly by electrons but as excitations of an underlying electromagnetic field. This works beautifully in the mathematics, yet it introduces a deep paradox. If the photon is nothing more than a field vibration, how does an electron in a definite place and time actually release one? And once released, how does the photon know where to go? The formalism provides probabilities. It tells us that the photon exists everywhere at once, but that certain directions and outcomes are more likely than others. This solves equations, but it leaves the physical picture strangely incomplete. We are left with an odd compromise, a photon that is spread out across space until it is detected, yet somehow still emitted by a single electron and absorbed by another in a definite instant. Wave-particle duality, in this sense, is less an explanation than a placeholder, a way of papering over the fact that the actual mechanism of emission and propagation remains elusive. But according to Augmented Newtonian Dynamics, the electron is not a passive participant in a mysterious field but an active agent that always strives to keep its base energy intact. It achieves this by mediating its energy through the emission of pulses of electrical energy. When the electron has an excess, it emits a photon, and when it has a deficiency, it absorbs one. In this way, the electron self-regulates and preserves its core energy. These pulses naturally form into a stable dipole configuration, and that configuration is the photon itself. By granting the photon a physical structure, Augmented Newtonian Dynamics overcomes several paradoxes left unresolved by quantum mechanics. It explains how electrons can generate photons of any wavelength or frequency on demand, and, crucially, do so in only a few femtoseconds, the unimaginably brief timescale required for the functioning of today's high-speed electronics, lasers, and quantum devices. In this picture, the electron is no longer a mere intermediary of an abstract field but the true architect of photon emission and absorption. In quantum mechanics, the frequency of a photon is non-existent, because frequency is a property of waves. The frequency of a photon is simply a way of saying what the frequency of the photon will be when it is in wave form. In practice, quantum mechanics borrows a wave property and attaches it to the photon through the relation E equals hf. Yet this frequency has no physical mechanism attached to a single photon. It is only a mathematical abstraction that is useful for calculating the energy of a wave, but has no real existence in the particle itself. But in AND theory, the frequency of a photon means the rate at which it is being emitted. This gives the term a concrete physical meaning. When we speak of a photon with a frequency of 500 terahertz, it means exactly that. Photons are being emitted by the electron at the rate of 500 trillion per second. By redefining frequency in this way, AND theory restores it to a measurable, physical process rather than a borrowed abstraction. A look at the rate at which modern technology processes data shows that such speeds are not at all unrealistic. Processors already perform billions of operations per second, and photonic systems extend this by many orders of magnitude. Thus, the perspective on frequency is not only conceptually clearer but also entirely plausible in light of modern technological benchmarks. We have noted how photons are produced within the electron. But how do they travel through the universe? Why do photons always travel at sea when traveling through space? AND theory says they move through a background made of dark matter, created at the time of the Big Bang itself. At that moment, as matter formed, every particle was accompanied by the release of trillions upon trillions of photons each second. The Big Bang was not only energy but a tremendous amount of light also. These photons had nowhere to escape. As space itself expanded, they were carried outward with it, their energy steadily thinning, like light stretched by cosmic redshift. Over billions of years, their energy fell to an unimaginably small value, about 10 to the minus 50 joules. At that point they could no longer exist as real photons. Instead, they persisted as virtual photons. This ocean of virtual photons, virtual electric dipoles, which we now call dark matter, permeates every corner of space. And it is through the alignment of these virtual dipoles that light is able to propagate, and through the same alignment that gravity makes its presence felt. In this way, the dark matter sea of virtual photons becomes the medium for both light and gravity. This sea of virtual photons that permeates the entire universe accounts for the fact that light always travels at sea in space. Accounts for the rectilinear nature of light and for the fact that light obeys the inverse square law but at the same time maintains its energy intact.